Hello everyone. Now we're going to be going over section 5.5, which is about multiplying polynomials. So we have four objectives. We want to multiply monomials, multiply a monomial and a polynomial, multiply two polynomials, and then we're going to multiply binomials using the FOIL method. So objective 1, we want to multiply monomials. So recall that we multiply monomials using the product rule for exponents. So if we're, for an example, if we had something like 8m squared times negative m, we would multiply our coefficients together, and then we multiply our variables. And when we multiply our variables, we can go ahead and add our exponents, since we're multiplying. So then we have our multiplied coefficients, which would give us negative 72. And then we have our variable m with our added coefficients, so 2 plus 1, which would give us negative 72 m to the power of 3. So when we multiply monomials, this is just multiplying using the product rule for exponents mostly. So something we've already gone over in previous sections. Objective 2, we multiply a monomial and a polynomial. We use the distributive property and multiplication of monomials. So for example 1, we want to find the product. When we want to find this product, we're just using our distributive property. So we're going to multiply negative 8m cubed by each term in our polynomial. So we use our distributive property, and we're going to have negative 8m cubed times 4m cubed plus negative 8m cubed times 3m squared plus negative 8m cubed times 2m minus negative 8m cubed times negative 1. Oh, sorry. It's just positive 1 in this case, since we used our subtraction symbol. So we took our monomial and now we are multiplying out and distributing this multiplication. So now we have our new equation after we've distributed. So we have negative 8m cubed times 4m cubed. So we're going to multiply our coefficients. We're going to have negative 8 times 4. And then we have m to the power of 3 times m to the power of 3. Then we'll have a negative 8 times 3 and an m cubed times m squared plus a negative 8 times 2 with an m to the power of 3 times m to the power of 1 minus, this is going to be negative 8 times 1 m cubed. So we're going to multiply our coefficients. Negative 8 times 4 is going to give us a negative 32. And we add our exponents of our variables. So we have m to the power of 3 plus 3 plus negative 8 times 3 is going to be negative 24. M to the power of 3 plus 2. 8 times negative 2 is going to give us negative 16. M to the power of 3 plus 1 minus a negative 8m to the power of 3. And now we just want to simplify. So we get negative 32m, 3 plus 3 to the power of 6, minus a 24m to the power of 5, minus 16m to the power of 4, and lastly plus 8m to the power of 3. So that's how we would go about multiplying a monomial into a polynomial. We're really just distributing this term and multiplying it by each term in our polynomial. All right, so now objective 3, we want to multiply two polynomials. Multiplying polynomials, to multiply two polynomials, we multiply each term of the first polynomial by each term of the second polynomial. Then we want to combine our like terms. So for example 2, we want to find the product. We're actually going to just distribute again, but now we're distributing an expression. So we're taking this entire expression here, x minus 4, and we're going to multiply by our polynomial x squared plus 3x plus 5. And what we're doing is we're taking this entire term and we're going to multiply it by 5, then we're going to multiply it by 3x, and then we're going to multiply it by x squared. And it's this entire term here. So we'll make a note of this. We'll multiply x minus 4 to each term in our first polynomial. So when we multiply this out, we're going to have x squared times x minus 4 plus 3x times x minus 4 plus 5 times x minus 4. So we've taken each one of our terms in our polynomial, in our first polynomial, and we're multiplying it by x minus 4, the second polynomial. And now we just want to simplify. So we're going to now distribute. So we're going to take x squared, distribute to x and 4. We'll take 3x, distribute to x and 4, and we'll take 5 distributed to x and 4. So x squared times x is going to be x cubed minus 4, so minus 4 times x squared, so we'll get minus 4 times x squared. 3x times x is 3x squared. 3x times negative 4 is negative 12x. 5 times x is going to be 5x. 5 times negative 4 is going to be negative 20. So now we have all of our terms. And we want to combine our like terms. So in this case, our like terms are going to be negative 4x squared and positive 3x squared and negative 12x and 5x. So we'll rearrange our expression here. So again, negative 4x squared plus 3x squared plus negative 12x plus 5x. And then minus 20. So now we combine our like terms. Negative 4x squared plus 3x squared is going to give us a negative x squared. Negative 12x plus 5x is going to give us a negative 7x minus 20. And since we have plus negatives in this case, we can just rewrite this as minus. And we'll scooch this all together. So we'll end up with x squared, x cubed, sorry about that, x cubed minus x squared minus 7x minus 20. So this is one way that we can multiply polynomials together. Another way that we can multiply polynomials together is we can use something called the rectangle method. So we can use a rectangle to model polynomial multiplication. For example, to find the product of 2x plus 1 and 3x plus 2, we can label a rectangle with each term as shown below. So in our first image here, or this first box, we have 2x and 1 and 3x and 2. So we want to list them in these ways. So we're just listing the number. Then we write the product of each pair of monomials in the appropriate boxes shown below. So once we've written this and we've separated out our boxes, then we multiply them together. So we're going to have 2x times 3x, which will give us 6x squared. Then we'll have a 1 times 3x, which will give us 3x. Then we have a 2x times 2, which will give us 4x, and a 2 times 1, which will give us 2. So we can write them out in these rectangles like this, and then go ahead and write the products in each box. Then we get that the product of the binomials is the sum of these 4 monomial products. So 2x plus 1 times 3x plus 2 we'll get 6x squared plus 4x plus 3x plus 2. So we take each one of our answers in our boxes. Now we're going to add them all together. And then we combine our like terms to finally get 6x squared plus 7x plus 2. So that's another way that we can multiply polynomials together. It does break it down and make it a little bit easier, but it can be a bit on the time-consuming side, and it definitely could take up some room on a piece of paper. Another very important method that we'll be learning is objective 4. We want to multiply binomials using the FOIL method. So when multiplying binomials, so binomials, this is going to be polynomials with two terms. The FOIL method reduces the rectangle method to a systematic approach without the rectangle. So the FOIL method is going to allow us to do almost the same thing as the rectangle method, except we don't have to actually draw a rectangle. So the letters of the word FOIL refer to the positions of the terms. So if we take something like x plus 3 times 2x plus 5, F is going to stand for the word first. You're going to multiply the first terms. So in this case, our first terms will be x and 2x. We'll multiply x and 2x. Then O is going to stand for the outer terms. We're going to multiply the outer terms together. And the outer terms are going to be the terms that are on the outside. So it's going to be x and 5. Then I is going to stand for the inner terms. So we're going to multiply the inner terms together. So the two terms that are on the innermost parts. So 3 and 2x in this case. And then the L last. We're going to multiply the last terms. So the last terms in both of these cases, in which I actually forgot to draw the arrow. So the last terms would be 3 and 5. So FOIL stands for first, outer, inner, last. So first terms, outer terms, I, inner terms, L, last terms. So that's how we write up FOIL. And this is the same method that we're using when we use the rectangle method. It's just that we're not actually drawing a rectangle. So if we multiply these together, this is going to end up giving us x plus 3 times 2x plus 5 is equal to x times 2x plus x times 5 plus 3 times 2x plus 3 times 5. Then when we multiply out, we'll get 2x squared plus 5x plus 6x plus 15. Then we combine our like terms, which are most likely going to be the terms in the center, to get 2x squared plus 11x plus 15. And that would be our product of the two binomials. So from the book, we have our steps here for FOILing. So the FOIL method for multiplying binomials. Step 1, we multiply the two first terms of the binomials to obtain the first term of the product. Step 2, find the outer product and the inner product and combine them when possible to obtain the middle term of the product. Step 3, multiply the two last terms of the binomials to obtain the last term of the product. And step 4, add the terms found in steps 1 through 3. So an example would be something like x plus 3 times x plus 5. Our first terms will be x times x, which is x squared. Our last terms will be 3 times 5, which is 15. Our inner terms will be 3x, and our outer terms will be 5x. So we'll have 3 times x and x times 5 to get. And we can combine them at this point, or we can wait until the end. It would be up to you. And we would get 8x in that case, so that our product would be x squared plus 8x plus 15. So let's go ahead and put this into practice. Example 3, we're going to find the product by using the FOIL method. So we have 9x minus 2 times 3y plus 1. So in this case, we actually have variables that are different. And we're going to see how this ends up. So when we multiply these together, we have 9x minus 2, 3y plus 1. So we're going to start with f. First, if we write out our equation 9x minus 2, 3y plus 1, we're multiplying these first terms together. 9x and 3y. So we're multiplying 9x and 3y. X and y are different variables, so we can go ahead and multiply 9 times 3 to get 27xy. So this is our first term of our product. Now O, let's label these first. Outer. So our outer terms in this case, when we write them again, 9x minus 2 times 3y plus 1. Ooh, draw my pen there. Our outer terms are going to be 9x times 1. We're going to get 9x times 1, which is just 9x. Then I, our inner terms, when we have 9x minus 2 times 3y plus 1, we're multiplying -2 and 3y. Since when we have minus 2, we know we can rewrite this as a plus -2. So we're taking this -2 times 3y. So -2 times 3y, which we can just take -2 times 3 times y, which gives us -6y. Then lastly, our last terms, writing out our expressions again, 9x plus a -2 to make it a little bit easier on ourselves, and 3y plus 1. We're taking our last terms in this case, so -2 times +1, which gives us a -2. So we've found all of our terms of our product. Now we need to combine. So remember, we're going to combine the parts of our product. So we have 27xy plus 9x plus -6y plus -2. And remember now, this is our FOIL. And just simplifying, we get 27xy. We can't combine our outer and inner terms because they have different variables, but we can simplify them to say plus 9x minus 6y minus 2. And that would be our final answer. So this is how you would go about multiplying polynomials and binomials for that matter as well. The FOIL method is going to be the method that I will use to multiply polynomials. You can use any method that you would like, but as we saw, there's definitely kind of a few different methods that you could use. So whichever one you like the best, you can go ahead and use. But for future reference, I will be using the FOIL method the most. So all right, that wraps up section 5.5, and we'll see you again in section 5.6.